first law involving friction. Friction is a force that is present when two surfaces are sliding on each other. We have a box on a table. If the actual motion is to the right, then our friction is to the left. So here it shows that friction, the direction of friction is parallel to the object surface, and it is opposite direction of the actual motion. Okay, so there are two types of friction that we will focus on. First is static friction, and second is kinetic friction. So, what is static friction? Static friction is a force that keeps an object from starting to move. This force, static friction force, it is a smart force, or we can also call it a variable force. Why? Because it adjusts itself. Box on a table, and we give a force of 20 Newton. The friction is going to give us back 20 Newton as well. And if we increase the force we give, let's say 30 Newton, it's also going to give us back 30 Newton. It will keep matching the force that we give until it reaches a maximum value. So this maximum value, once it's exceeded, the box or the object will start to move. So what's the formula for static friction? The formula is static friction force is less than or equal to the coefficient of static friction multiplied with the normal force. So I'm going to break down this equation for you. So first here we have the static friction. So the static friction is measured in Newton, and then we have the coefficient of static friction. So this value does not have a unit, and it is a constant value, but different for different surfaces, different value for different surfaces. And lastly, we have this, which is the normal force. So this normal force is measured in Newton. Oh, so for coefficient of static friction, it's basically a measure on how hard or rough or sticky the surfaces are, while the normal force is talking about how hard these two surfaces are pressed onto each other. Okay, so I'm going to give you an example of question. Okay, so a 20 kilogram box, this is the mass, on a horizontal floor, meaning it is in a contact, so normal force is equals to the weight. And it's also given us the coefficient of static friction, which is 0.4. So find the maximum static friction. So to find the maximum static friction, it's basically static friction maximum is equals to the coefficient of static friction multiplied with the normal force. So we just put in the value 0.4 times, as we know the normal force is equals to the weight, so 20 kilogram times with 9.81, which is our gravity. So we're going to get the value 78.48 Newton. So this is the maximum static friction of the box on the horizontal floor. Now, B. If a horizontal force of 15 Newton is applied, will the box move? So in this case, it will not move. Why? Because 15 Newton, which is the force that is given, is less than the maximum static friction, which is 78.48 Newton. To make the box move, we need a force that is greater than 78.48 Newton. So that is all for static friction. Thank you.
So now we will continue with kinetic friction. So in this topic, we will look at the direction of the force, factors affecting its magnitude, and also the formula. So what is actually kinetic friction? So kinetic friction is actually a force that opposes the motion of object direction, and its job is to slow the object's motion. So the key word here is opposes the motion of the object direction, means that if the object's direction is toward here, the direction of the kinetic friction is here, towards the left. Why? Because it always opposes the motion of the object's direction. Second one is factors affecting its magnitude. So actually there are two factors that affect its magnitude. First one is actually normal force. So what is normal force? Normal force is a force that pressing the two surfaces together. So if we look at this diagram, so the object, the box is on the table. So first one is the weight. Weight is always towards the center of the earth. So if the weight is downward, the normal force actually is upward, like this. So the second factor is nature of the surfaces. These factors actually refers to how rough or smooth the surfaces are, because the coefficient of kinetic friction depends on the nature of the surfaces. If we look at this table, this one is a rough surfaces. Meanwhile, this is a metal table that has a very smooth surfaces. So the coefficient of the kinetic friction for both tables are different because it depends on the nature of the surfaces. So the formula is kinetic friction equals to coefficient of kinetic friction times normal force. So FFR equals to kinetic friction mu K is coefficient of kinetic friction, while Fn is normal force. So you don't have to worry about the coefficient of kinetic friction. Because of why? Because coefficient of kinetic friction will be given in the question. So don't worry about that and don't bother to remember every surfaces. So let's take a look at the sample questions that I have here. So the question said that this kayak is descending a 30-degree slope at a constant speed. So the keyword here is constant speed. So it says, what can you say about the coefficient of the kinetic friction, which is mu K? So let us take a look at the keyword given in this question, which is a constant speed. A constant speed means there's no acceleration, so automatically acceleration equals to 0. When A equals to 0 means that our net force is equals to 0 or balance. Right? Okay. Let's take a look at the diagram to resolve what the force we have here. So first of all is weight. Weight is always towards the center of the earth, so means that is downward. Okay. So is, we put it as Fg. Fg equals to mass times gravitational acceleration. So for the x component, we know the x component is always inclined to the x-axis. So here, so this one is x. So y component, y-axis is always perpendicular to the x-axis. So here. So here is y. So the angle here is same with the angle here. So this one is okay. Okay. So let's determine the force. So for the x-axis, we would say that the direction of the force, the direction of the motion is towards the x-axis. So here is the direction. So here is we got Fgx. So the normal force is always to perpendicular to the surface, right? So here is the normal force. Normal force actually equals to y component. So for the kinetic friction, like I said before, kinetic friction is always opposes the motion's direction, the object's motion. So if the motion is downwards, the friction is upward. So here is the friction. So let's solve this problem together. Okay, the first one is, okay, when I, like before, I said that net force is equals to 0 or balance, means that our Fgs is actually equals to the friction. Because of why? Because our A is equals to 0, means that there is no acceleration and the net force is balanced. So the x component equals to the friction. So actually FGX is mg sine theta. And for friction, we know that the formula again just now. So this one is the formula. So mu k Fn. So what is Fn? Fn is mg cos theta. So we can rearrange this formula, which is we can cancel out both mg for both sides. So we have mu k equals to sine theta over cos theta. So let us insert the value. Mu k equals to sine 30 over cos 30. So mu k equals to 0.58. So here's your final answer.